Alright, so I'm be doing number 52. This is the problem. Y double squared minus y equals 8e to the power of t sine 2t. And we're given initial points at y0 equals 2 at y prime 0 equals -2. So first step, take the Laplace of both sides. Take the Laplace of y double prime and then Laplace of y. Double y prime gives us this right here. Then we just keep the Laplace of y, bring it down there. Alright, so then we take the Laplace of aet to the sine 2t, and we get this right here, because it is a shifting problem. Our shift is by 1, as you can see here. This will match our shift. And sine 2t is this, but we do have that shift. So by our general formula from the section, our forcing function s minus a, shift is 1, so we have to subtract that from our s, and we get this. Alright, so now our Laplace of aet equals 8 Laplace of e of t, which is as minus 1. Moving on, so our full Laplace is 16 when you multiply the 8 and then 2. S minus 1 squared plus 4. Alright, now, so our full equation, once we combine our first Laplace on this side and then that side, is this. Moving on, we plug in our initial values. Get that, we will add 2s minus 2s. This will cancel out, add on to this side. Then we will factor out the Laplace of y's. Now we get s squared minus 1. We divide everything by s squared minus 1. It's right here. We do some simplification. Follow along. I just distribute this and distribute all of that, and I get that. Then simplifying, just bring the denominator over there, bring this down, get that in the numerator. Alright, moving on. Now, you get this. Now we have to take the inverse Laplace. But if you can't, you don't know what this is. So in order to do this, to take the inverse Laplace, we need to do partial fraction decomposition. And this is the hardest part of the problem. So from Calc 2, I used the formulas, what I remembered, and I split this up because I have to the power of 3. So this is how I split it up. And I found the roots after we were gonna plug in for our s's, -1 and 1, as you can see from here. Alright, so multiply by the denominator, everything, so all this will cancel out, and then you'll get your equation on the right. It looks something like this. This is just this down here, just didn't fit. Alright, so we plug in the -1 that we found from our roots. Once you do that, you will find out that this is -16. All this is 0, so this will cancel out. And then this is 8, and then this is -2, so that's how you get the -16. And this is 0, so all this will cancel out. So C is equal to 1. Moving on, so we let S equal to 1 from here. Plugging all that in, we once again get some zeros, and we just have a 4 times 2 from here, and we get a 16 from here. Notice just -1, you just change it, so it's 16. So 16 equals 8d, d is equal to 2. Now, we're gonna plug in our C and D that I found from here into our equation to find our B and A. Alright, once we do that, you can simplify this down a bit. Just distribute a lot of work here, so I kind of simplified it just sake of time. Simplified that down, and then we're gonna have to group according to their powers to find our B and A. So moving on, so take all the s cubed, s squared, s, all of our constants here. So we'll do a little example. So s cubed is 2, so we get to 2 here, and then bs cubed, so we take the b, and then the 3 from here. There's no other cube, so we do that for every single one, and we get this. And I went and go ahead and solved for a. Subtract the a, divide by the negative, a equals -1. Then to check, we plug in a equals -1, and turns out to be true. Perfect. Now we do the same thing for b, and we find out that b is also equal to -1. We check that, and then everything checks out. So our a is -1, and b is also -1. So now we found our c, d, a, and b. Now we could plug it back into our partial fraction composition and split this up. So as we can see from here, we're going to need to complete the square, and that's how you do it. And you get this. Notice the negative constant here, -1, or -2. Don't forget about that later. So we're gonna have to take the inverse Laplace of this and this. So I labeled this as 1 right here, and then this will be my 2. So I completed the square, and using the general formula from the section, there's a shift of 1, as we notice. So my f of s is my f of t. This looks like cosine. So my s minus a, which is going to be 1, and then don't forget that negative. Remember that negative right here. So add that negative to the e to the t, shift the 1. Then this is my cosine to t. That's that. Then this is my second part right here. So the plus of that, our shift is once again 1. F of s is a sine. Make that into a sine 2 squared. I mean s squared plus 2 to the power of 2. Multiply by 2. Take out this 1/2. Take the plus of that. That's just sine 2t. And we get that. Don't forget the -2. You should have a -2 here, but I'll add it later. So third part is from here. So take the Laplace of this and this, 3 and 4. That's where this comes from. E to the -t, pretty simple. Then to e to the t. Then I included the -2. That should have been here. I just included it later. And then these two will simplify, and this is your final answer.